This video will guide you through using the curvature and sinkhole identification codes used in the paper Improved Automated Mapping of Sinkholes Using High-Resolution DEMs. This code was created in R. If you are unfamiliar with R, we suggest that you use RStudio because it's fairly easy to navigate. You will see RStudio being used in this video. The curvature code approximates the curvature at each of the boundary points for each region and outputs summary statistics. There are two input files needed for this code, and both should be CSVs. The first contains the data for the region centroids. There should be 3 columns. The first should be the FID, which is the region number. Note that the code is expecting that to be the exact title of the first column. The next 2 columns give the X and Y coordinates for each region centroid. Here is an example. The second input file contains the data for the boundary points of each region. Note that these points must be in order so that they trace the boundary. It doesn't matter if it's clockwise or counterclockwise. The column headings here are the same as for the centroid data. Here is an example. Note that all of the values for region 0 are given first, followed by region 1, and so on. There are 5 changes that you should make to the code to run it for your own data. First, change the name of the working directory. This should be a path to the folder that contains your data. Next, change the name of the file that contains the centroid data. Then change the name of the file that contains the boundary data. Next, decide which curvature statistics that you want to compute, or you're welcome to leave the default statistics. You will also need to change the variable numstats if you want more or less than 5 statistics. Finally, change the name of the output file if you don't want the default name. To run the code all at once, click Source. You can see the output by clicking on the curvature output variable on the right side of the screen. You can also see it in the file that you saved. Here is an example. The sinkhole prediction code uses prediction variables to classify each region as a sinkhole or not a sinkhole. There are 2 input files needed for this code, and both should be CSVs. The first contains the training data. The first column should contain the FID, which is the region number. The second column shows whether the region is a sinkhole or not. 1 signifies sinkhole, and 0 signifies that it's not a sinkhole. Note that the code is expecting to see the sink not sink heading that you see here. Following that should be columns with each of your prediction variables. Here is an example. The second input file contains the new data that you wish to classify. The columns are the same, with the exception that there is no sink not sink column. Here is an example. There are 7 changes that you should make to the code to run it for your own data. First, change the name of the working directory. This should be a path to the folder that contains your data. Next, change the name of the file that contains the training data. Then change the name of the file that contains the new unclassified data. Next, change the number of models. By default, this value is 15. You can change the formulas for the different models if you do not wish to use the default models. The formulas contain the names of the variables that you have in your spreadsheet. If you are using more than one variable in a model, separate the variables with plus signs as you see here. Next, change the cutoff value for logistic regression if you want it to be something other than 0.5. Finally, change the names of the output files if you don't want the default names. To run the code all at once, click Source. You can see the output by clicking on one of the output variables on the right side of the screen. You can also see your results in the files that you saved. Here is an example. The code and example files from this video can be found on GitHub. There is a link to the repository in the description.